Alright everybody, welcome back to another Ask a Dev Unreal Engine tutorial. My name is Kevin. Today we're going to be hopping into a second version of Lookat using Control Rig. Now, we did a version and it works pretty well. It actually works really well, but there's one piece about it that really bugs me. I'm going to show you here in a second. But before we get into that, I am going to be moving a little bit faster through this tutorial. We're going to do it from scratch, but we do have a lot of knowledge we learned during the last one. So if we're moving too fast, you can always go back and watch the first one as well. But hopefully this will also be standalone. As always, thank you for being the best part of this adventure, the community. Appreciate your support. You can find tips down below, Patreon. We also have the Discord hopping in, lots of people hopping in, helping answer people's questions. It's awesome to see, and as always, spreading the word. So first, let's hop into Unreal and let me show you why I'm inspired to do a different Lookat method. And I do want to caveat this. I have done limited testing in production on the second method, but it looks promising so far. Let's go. All right, taking a look at what it is that has inspired me to come up with an alternate method and what is it that's driving it. For the way I kind of was taught through rigging, the default pose of the character is very important for a lot of different reasons. And one of the things that you want is you want your default pose when you first build your rig to have zero effect on the character's pose. Because what that can do is that can add in offsets, it can add in confusion. Is the issue that you're seeing is a result of the pose, the joint orients, the rigging, what's it coming from? So the idea in this first method that when I pointed this out, you can see it slightly if we disconnect our forward solve. Watch the character's spine. See how the character stands straight up and down? And when I connect this forward solve, the character leans back a little bit. I talked about this a little bit while we were building this. And the way we mitigated that is we lowered the influence on the lower spine. And we did that by setting this multiply. If I turn this back to 1 so it has full effect, this is our character's default pose with this Lookat. This bugs the way that I was brainwashed into rigging, and because this definitely would have an effect on almost any pose that's on the character depending. And so the idea that this character by default is switching from this standard pose to this scared pose just by adding in this Lookat, even though the Lookat works, even though it looks good, if we pick this and we move it around, our Lookat totally works. But it has that offset. So I had an idea for a version of this Lookat that does not have the offset, and that's what we're building today. So let's get started. All right, so here we go. In order to get started, we need a control rig. So let's go ahead and make one. We'll just right click on our skeletal mesh, create a control rig, and that's going to pop down here. And I'm going to rename this, let's call this method B. And then let's open that up and get going. Now we have our, stock this over here. We have our main parts. We have our construct, our forward solve, backward solve. We're only going to be working with our forward solve and our construct. So starting with our construct, the major pieces that we need are, we need the 3 controls that we're going to be looking at. So if you didn't do our first tutorial, what we need is we need a transform in space in front of our character that they look at. And what we're going to do is in our Anim Blueprint, we're going to basically set that. So our character always looks at that. So we're going to create that control. Then we're going to create a child that we can use for debugging, and one more that we can use as an offset for our chest so we can get some nice follow with our chest that kind of lags behind. We'll show you how to do all that. But first, we need to create those controls. So let's get our construction script in here. And let's see here. Let's add construction. And we need to spawn a control. And the control that we're going to spawn initially is going to be our Lookat world space. I think that's probably pretty good. And then where do we want to put this? For the initial version, or for our testing, we're just going to put it basically right in front of our character. So to get this to be right in front of our character, all we have to do is we can just get the head position. So let's get the transform of the head, get the transform of a bone, in this case the head bone. And then what I want to do is I want to take this, and I'm going to take this transform and I'm going to basically put it 100 units in front of our character. So to do 100 units in front of our character, because we're connecting into a transform and because of the way transforms work, we basically, in matrix world, because it's a transform matrix, we multiply. So if we multiply this by just simply saying multiply, we're going to get a second transform. And in our second transform, let's change our translation. In this case, we can look, we want it in front of our character. And if we look in the bottom left, we can see the axes. We have Z, X, Y. So we are going to put it 100 units in front of our character. And let's go ahead and connect that to the translate. Now, before we can just connect this into the translate, I want to right click this initial value and change this to a transform. We'll leave the rotations as 0 and we'll just connect in the translate. So when I do that, what we need to make sure is that we're set to global space for everything, and then we have our look at, and all of that is good, and then we'll get our initial for the head. So let's compile, and you'll notice when we do that, that pops this look at control to be straight in front of our head by 100 units, which is exactly what we want. So let's collapse this down just for space. And then let's make a couple of changes to the settings for our transform shape. In this particular case, I would like this to be a cube, just so that I know for sure. So I'm going to call this a box thin, and we will change the color. In this case, over here on the right, I'm just going to click and I'm going to choose yellow. So now we have a yellow box that we can use as our cube. If I collapse this down, we now have our look at transform. So we need two more that we talked about. One is going to be our look at control. So we can actually just duplicate this. This is going to be our look at control. And we're going to need one more, and this one is going to be our chest offset. So this one, let's rename chest offset control, for example. And these are going to get connected in and parented appropriately. So our first one is going to get connected in and parented to our look at. Our second one is going to be the same thing, except it's going to get parented to the look at. The look at control instead of the look at world space. So this look at world space is going to get set by the Anim Blueprint, or whatever's driving where our character is looking. The second one is, this is kind of here for debugging, and we can use it as an offset if we want to, and this is going to be our chest follow. But let's make a couple more changes to the shapes here. I want this one to be a sphere, let's say. Let's go sphere thick, so you can see it. That way it's different. And then over here, we will go ahead and set this shape to sphere again, but we'll go sphere thin. Sphere thick is fine, but let's just make it, maybe we'll make it a little bit of a different scale, because I want to be able to see it. So let's change this to 0.7, for example, because later on it'll help us visualize what's happening. And for the color, for the internal one, let's just go with 1 and 1 for our offset. So now we have our three transforms. And you can see them all here in space where we want them in front of our character. So let's compile and save this. Save frequently with control rig. I've noticed a lot. Now, nothing too special happens here when we translate our controls. They just move together. That makes sense. They are sharing a parent-child relationship. Okay, so the next piece of this is going to be setting up our control hierarchy. This is a little bit different than what we did in our method A. So don't get caught by surprise here. What we're going to do, let's move this down. What we're going to do is we're going to basically replicate the entire spine history all the way through to the head. We're going to create two controls per joint. One is going to be a 0 translate rotate that's basically kind of tracks where we are in space, and the next one is going to be a child of that, which we're going to use to get the offsets from, potentially. So to do that, let's make a couple changes here. I'm going to drop in a sequence node. Let's drop in a sequence node by holding the S key, or you can right click and type sequence, either way. Control drag to move this pin without having to hunt around for where it goes. And we need a couple things. First, in order for our control hierarchy to get set up, I do want to, basically if we scroll down here, I do want to, basically if you look down here, we have these. Let's create a root control. So let's spawn a control from here, spawn a control. And this control is going to be called our root control. And we are going to make an empty transform for that because this is going to be around the character's feet. So we don't need it to be anywhere in space. We can just plug that in. I believe we can also unplug that and compile and it still works. So we don't even have to carry that around. Once we've set this pen type, we know it's the default value. So we have our root control. Let's set some of our shape settings just to be consistent across our projects. So for this one, let's change our type to be a hexagon, and we can make it thin. And then let's make our scale. Let's go 9, 9, and 9. And then our rotations and everything look good. Let's just make our color something like an orange. Okay, just so it looks clearly different than our yellows, which is good. Okay, so we have our root control. Now what we want to do is we want to, basically every control we make from here on gets parented to the control that was just made. So the easiest way to do that is we're going to use a variable to help us out. So let's take and create a previous control variable, previous control. And this is going to be a rig key element. And a rig key element can be a joint, it can be a control. So we'll just do rig key element. And then what we want to do is we just made the root control. So we want to set our previous control to be the root control that we just created. Okay, so when we compile and save that, you can see in our rig hierarchy, we now have our root control down here at the base. All right, so now what we need to do is we need to loop through and create all of the controls that we're going to be using, mostly from a visual standpoint. I'm doing this with controls to help out from a visual standpoint. You could probably do this with nulls or another way, but I like the controls because I want to see what's happening. So first, let's take our spine all the way to our head, drag and drop, create an item array. This is an array of every single joint that we want to create our look at controls for. So I don't need to look at this anymore, so I'm going to collapse that for cleanliness. And then let's take, and for each one, I just said it, for each control, for each joint, we're going to create 2 controls. So let's do that. So the names of those controls, I already mentioned earlier in the foreshadowing. Let's concatenate this. We're going to take the name of the joint and we're going to add underbar ZTR. That's going to be our 0 translate rotate. And then we're going to concatenate again. And this one I am going to call underbar ATT for our attach node or attach point. Okay, so we have 2 of those. So all we need to do is spawn a control. And the control that we're going to be spawning first is going to be named the ZTR. And what we want to do is its parent is going to be our previous parent. So let's get our previous parent. So right now, the first time through, the previous parent is the root. So the first time through this for loop, our previous control is going to be the root control, which is exactly what we want. Okay, so now we have our ZTR. Let's set our initial to be a transform. And the transform that we are going to use for that is going to be the transform of the joint. So let's, actually, is that still connected? Yeah, okay. So let's just get the transform of this joint, of this bone. And we do want the initial. We're going to get that in global space, and let's plug that into our initial value. All right, now when we compile this, we should see a control basically in our hierarchy. If we look at our hierarchy, you'll see we've created a bunch of controls. However, we have not finished yet, and so as a result, they're all currently parented to the root. But I do want to change my control shape because I would like it to be something that is easy for me to see and debug with. So I'm just going to go with arrow thick, and let's change the color. I want the color to be something outrageous so that I can see it. So maybe not too outrageous. Let's just do light blue, for example. Okay, and then I'm going to compile that, and let's set our scales underneath our shape transforms, our scale. Let's try, Y is going to be forward. Let's go 8 in Y. Let's try 4 in X, and 1 in Z should be fine. Okay, so you'll notice we have very large arrows. We could probably go 3 and maybe 7. Sure, that's fine. All right, and I do also want to rotate them. Let's go 90, so they're flat, and flip them around 180, so they're pointing forward. So compile. So we have all of our joints now represented as controls that are arrows that are pointing which way they're looking at. The reason I want to do that is because we're aiming at something. I want to be able to look at which way it's aiming. I want to be able to see it when I'm debugging this. So let's collapse this down, and we are going to do the exact same thing again, but this time the name of the control is going to be the ATT. That's why we created this one. All right, and we do want to change, and the parent for the ATT is going to be the 0, for the attach is going to be the 0 translate rotate. So let's parent that in, connect it up, and if we compile this, we now have double arrows, but we can't see them. And if we, so let's change our shape, just so once again, for debugging, let's try 2 and let's say 5. Okay, so we have a second set of arrows now. Let's change our color to be something completely different. Let's go with a bright yellow so we can see what's happening. Okay, so now we have successfully created our arrows. They're all pointing the right way. They're pointing currently where the joints are pointing. We're going to change that here in a second, but we do need one more step, because if we look down here in our hierarchy, you'll notice that all of our 0 translate rotates and the ATTs are parented properly, but they're not parented to the previous control. That's because when we're done at the end here, we need to set our previous control to the last one that was created. So we'll set our previous control like this. And then what's going to happen is the first time through, and we actually do need to, as a result of that, we're going to need to change some of our spacing. So let's go ahead and do that. What we want to do is we want to set this to be global space. Sure. Wait. These are, let's make sure we're not confusing these. There we go. Global space. Okay, so there's different ways to do this. This is global space. This is local space. Technically, this works because it's relative to the parent. There's a bunch of different stuff to do that. But we could also, just to be consistent, we could change this to global space as well, and the transform. But if we do that, we need to make sure we get the bone initial transform for the transform. Otherwise, everything's going to be changed. So as long as you understand the parent-child relationship, you can choose to kind of set these however you like. In this case, we're using them both in global and getting the joint position as the initial starting point. Okay, and now the first time through, our previous control is the root control. We go ahead and create our ZTR, then we create our ATT, and then we set the previous control to the ATT. So the second time through, our previous control is the last ATT. So now, when we look at our hierarchy, you can see we have basically recreated an entire hierarchy of all of the controls that we want to use to potentially aim at this object. Now, our goal here is to set it up so that when we aim at this look at, we are not changing our joint's initial rotation. So we're going to have to bake in some offsets. So let's take a look at how to do that as part of our construction script. And then we'll be able to then we'll be able to wrap up our construction script. Okay, so in order to bake in the offsets, let's make some room here. Technically, what we want to do is we want each of these arrows to point at our look at control when it is initially created. So the way we're going to do that is with an aim. And the object that we're going to be aiming is our 0 translate rotate. And the object that we're going to be aiming at is the position So let's get the transform of our look at. So we need the transform of a control here, and that is going to be our look at control. This is the one that we're going to look at. Now, I only want the translate position, and I believe we can just connect this straight in to our target. Okay, when we do that, everything's a little messed up. And the reason it's messed up is because all of our axes are messed up. So here's what we need to do. Let's double check. We don't want X to be our axis in this case. We actually, remember, we're pointing forward. Y is forward for this. This may, if your joints are set up differently, if your controls are set up differently, you basically may need to play with these values to figure out what works best. So now all of our controls are at least pointing at the look at, which is great. However, our secondary axis needs some help too. So our secondary axis, we're going to change, and we're going to set that to be the X axis for my setup, and also the default one if you're working with Manny. And then the target is going to be Z up. Okay, so if we compile that, you'll notice that all of our blue arrows are actually pointing straight at the look at, which is perfect. That's what we want. And I do want to change my target kind to be a direction instead. Okay, so they're all pointing straight at that look at, which is great, in the direction of that look at, basically. All right, so let me collapse this down and make some room to make this a little bit more readable. Okay, so now that we have our aim, there's a trick here. What we actually want to do is, if we look at our, let's see if we can see this. If we look at our aim, you can see that we have these current rotation values and everything in there. What I want to do is I want to bake that into the control. So we're going to try something a little bit crazy here. And as part of our construction script, what I'm going to do is I'm going to set the transform. So let's set the transform. And the transform we're going to be setting is of our ZTR. So let's make this a little bit cleaner to follow. Okay, we know that this is going to connect in here. We're just cleaning this up so that it's easier to follow. And then we're also going to connect it in here. Now the transform, what we're going to be setting it to is we're going to be setting it to, now that we've done this aim, we're going to take that and let's get the transform. So get the transform, and the transform that we're getting is coming from our ZTR that we made here. That's this one. So we're going to get the transform of that. And I've never tried it connecting straight to the item, so I may have to go back and connect it using the name, but for now that hopefully that'll work. And we're going to use global space in initial. And then let's go ahead and I think that's what we want. All right, and then let's set this into our initial value. Okay, and then see where we're at. Global space, and we want to set the initial value. Compile. Okay, so let's see where we missed it. The item that we're setting is the control. The initial value is not the initial. We want the current. My mistake. It's the initial for the set. So what we're doing is we're aiming that control, the ZTR, at the look at. Then right after we finish aiming it, we're taking those values as they are, not the initials, as they are, and we're plugging those back in to the control, even though this is registering as a bone. I don't really like that. I would like to see that as a control, so I'm actually going to specify this explicitly. I'm going to take this ZTR and I'm going to connect it in to here as a control. Okay, I just want to make sure that this is correct. Okay, so now that we've done that, if we take a look at our ZTRs, remember before when we were looking at them, when we looked at our current, they had values in these rotators, 0, 0, 0 now. So we've effectively zeroed those out. This is now the 0 point now. However, as a result of that slight change, we do need to update our spawn transform for our ATT follow nodes, because we actually do want those aiming at the same thing, but not actually aiming. What we actually want is we just want them to be defaulting to 0. So let's break our initial value, Let's set this to local space and compile it. And what we've got now is we have all of our zero translate rotates aimed at our look at, and we have all of the offsets also just aimed by default because their transforms are set to 0 in local space. And the big key here, or the trick, is this aim immediately getting that value and copying it into and setting that as a new initial position of each of our individual controls aim ats. Okay, so there are a couple of other things that we are going to do in our setup, but we're going to do those later. We're going to get this working, and then what we're going to do is we're going to come back and set it up so that we can connect this into our animation blueprint. So for now, that wraps up our construction script. So now let's take a look at the actual forward solve, which should be hopefully pretty straightforward. Let's take a look at it. Make sure we save everything before we get started on the forward solve, and here we go. In our forward solve, we are also going to use a sequence again, once again holding S, and we are going to have a few pins off this. So I'm going to create 4 pins. For initially, I'm going to leave the first pin blank because this is going to come back. We're going to come back to this once we plug this into our enemies. So on our second pin, what are we going to do first in our forward solve? Let's set up the lag for our chest. So to do that, we're going to use a spring interpolate node. So here we go. Let's do a set transform. And the transform that we're going to be setting is going to be a control. And in this case, it is going to be the chest offset. Okay. Now, what we're going to set it to is we're going to set it to the current location of the look at. So let's get the transform. And this one is going to be a control, and this is going to be the look at control. Now, here's where the physics happens. What we're going to do is we're going to put in a spring interpolate. So here's our spring interp. And if you just look at what we have here, we have a target, we have a current, and we have a result. So let's connect in the translate of the look at to the target. When we do that, that's going to convert all of our pins to be vectors, which is perfect because we want to use this vector. If we convert this to a transform, we want to use this to plug into our translate. So by default, we're taking the current, or we're taking the look at, that's going to be where we're trying to get to. We need one more. We need where is the chest offset currently. So once again, let's take a look at our items. In this case, let's take the chest offset. Okay, and we'll feed that into the current. So what we're looking at is we have the current position of our chest with a target of the look at, and then we have all of our spring interpolate and dampening. So let's compile and save this and just test it real quick. If we move this, you can kind of see the white sphere falling behind. And if we reduce our strength to 1, you'll see it really falling behind. See how far behind it is? So what's going to happen is our head is going to be looking at the box, and our chest is going to be looking at this sphere that's falling behind. So we're going to get this nice or more organic offset for our characters. Now, a couple of things to point out here in this critical damping, just in case you didn't go through our first stuff. The explanations here are great. If you mouse over this, set this to smaller than 1 to make the spring oscillate so it'll bounce. We don't really want that because we don't want our chest to bounce. Set it to 1 to go to the target without overshoot, and higher if you want it to get there slower. So 1 is fine for our purpose. All right, so we have our kind of like physics delay set up. Now let's get into the hierarchy. All right, so what we're going to do is, as we did before, we're going to get an item array. And I think we'll just go ahead and let's do head and neck first. So we'll get these 3 joints, create an item array, and then what we want to do with this is, once again, for each. So for each, we'll plug into our C, and we're going to need to get some of our information, or basically construct the names of our controls. So let's concatenate again. And we want our ZTR, because what we're going to do is we're going to constrain the zero translate rotate to the joint. Okay, now, so here we go. Let's create a parent constraint. Parent constraint. Here we go. And if we set this up properly, we are going to be constraining the control, which is our zero translate rotate, to the parent. In this case is going to be the item. Okay, and we are going to maintain our offset so that way it stays where it is initially. And then let me just double check something. I want to make sure. Yeah, our character is not moving. Notice our spine is not changing. That's what we want. We don't want our spine changing. Okay, so we're concatenating the name of that. So we have our parent constraint. And then what we want to do is we're going to go ahead and do our aim. So here's where our aim is going to happen. So let's do aim. And this is going to be almost exactly like the previous aim that we set up. The difference is if we open this up, we do need the ATT. So let's copy this. And the item that we're going to be aiming in this case is our ATT. So it's the control, and it is going to aim at, and the location is going to be, let's get the transform. And in this case, the location is going to be a control. The control is going to be, because we're doing the head, we want this to be the look at control. So let's get that value, and then let's get that translation, and that is going to connect into our target. Okay, now you'll notice that all of our X values are messed up for our head and neck. That's because we do need to reset our axes to be the same. It probably would have been easier just to copy the previous aim because it has all of the settings already done, but we can just reset these pretty straightforward. If we go 1 and 0, we just need to make these match. 1 and 0, and then direction. Okay, so once again, we still should see no movement because we haven't actually moved anything yet. But if we move our look at now, see how our ATTs are now aiming at it? That's what we want. Okay, so let's compile and save. So we've got it so that this is our neck and head. That is working. Now the one thing I do want to do is I want to connect in some fall off. So we get a nice kind of fall off. So let's take our ratio and connect that into our weight. And let's see what that looks like. There we go. So we have fall off. Now we're technically, because of the way the ratio works, we're technically not moving the base of the neck. We may want to change that. So for now, just for testing, let's just disconnect it and we can figure out fancy stuff on that afterwards. Okay, so that's our neck. Now let's do our spine. We need to do the exact same thing for our spine. All I'm going to do is I'm going to take all of this and I'm going to copy and paste it. And this is going to connect into the complete. And the difference is the array that we're going to use is we're going to use all of our spine joints. So let's create an item array from our spine joints. And what we're doing here is now we're going to loop in on our spine joints. All the ZTR should be the same. The difference is the look at. So if we just keep it the same, look at what happens when we look at this, when we move it. If I can grab it, you'll notice that the neck, everything, they all look the same. There's no offset. However, if we just simply change this to our chest offset, compile this, when we move this, look at the delay in the chest joints. See how much they get there, but they're slower. So that's going to give us this nice delay in the way things are working. So let's go ahead and compile this. We do have a note. What is this note? Oh, interesting. Okay, so it is worth pointing out that technically here we're doing our neck after our spine after our neck, and our neck is technically parented to our spine. So just for safety, let's flip these. Let's do our spine first and then our neck. So I'm just going to flip these around. And what we'll do is we'll connect into here instead and just reorganize this. I think when I originally did this, I did this as one array and I put in an if test. So here we go. All right, so now we have spine, then we have neck. Let's see if we compile, if we get rid of that. Great. Okay, so that takes care of that little blue warning. So now all we need to do is constrain in our joints. So once again, we are going to take the item array, and for each one, and I am going to split these up just for consistency, and also just in case we have some cool ideas of other stuff that we want to do. And all I want to do is for each one, let's get the name of the ATT. So we need to concatenate. Zoom in here so you all can see. And we should be starting with the spine. Yeah, we are starting with the spine. So we're going to concatenate that. And let's just do a rotation constraint. This should be pretty straightforward. Rotation constraint. Now, what are we constraining? The child is the joint. So we want to constrain the joint. And what are we going to constrain it to? We're going to constrain it to the control, which is our ATT control. So in this case, we'll set it to control, and the value of this should be our attach control. So let's feed this in here. And then actually, we could even use the ratio here for our rotation constraint, that way there's fall off. All right, so now if we've done this right, first off, you'll notice my character doesn't move. And when we move, you'll notice the chest moves. It's already working. And you can see how far behind the chest is. We'll change that setting, but we're almost there. We're almost done with the majority of the work. So let's take this, and on complete, let's just go ahead and get our head neck. Okay, so let's get an item array. And let's plug that in to here. We'll come down on completed, compile and save. And now what we should have is head goes first, then chest behind. It's very snappy, but it totally works. It looks pretty good. So what's happening is, and then we have the same thing when we look down and we look up, depending on where it's going. Now let's fix our fall off to make that feel a little bit more natural. And then we will move on to connecting this to our animation blueprint. So let's make this a little bigger for our testing. Compile and save as always. And now I think 2 feels pretty good. You might go faster, but you can tune this to whatever your taste or whatever works best for the idea of what it is that you're trying to give for the spirit of what your characters are. So at this point, we've done it. We've actually got it so that our look at is working. And the big thing, the big goal for this was we wanted to create a look at where if it started out without any offsets on our bones. And so when we disconnect our forward solve, you'll notice that it has no impact on our character pose. So the hope with this is that the incoming pose will not be corrupted at all by the control rig, and the control rig is going to basically just do what it needs to do based on where this look at is. So as I reconnect this, nothing has changed. Okay, so what do we need to do now? We need to go ahead and set up for our, let's see here, we've got our 1, we've got our 2. Generally speaking, I do like to connect these in a little bit differently. So right now I have, this is technically this section right here. Let me make this smaller. One little bit of cleanup before we start on actually connecting it to our animation blueprints. Okay, this section here is doing the aiming of the controls. This section here is doing the rotation constraints. So what I like to do is, rather than daisy chaining these, I'm going to actually plug this in based off of the last pin. So that way it's clear. And I may have done that wrong. I did do that wrong. I actually want this at the bottom. So our last pin is going to be the rotation constraints, and our pin C from our sequence node is going to be the aims. So this here this is the aiming of the ATT, for example. That way it's kind of its own compartment. So aiming of the ATT. And then down here, this is just simply the rotation constraints. So they're kind of compartmentalized. Let's make this a little bit. And we can compress this actually, collapse this down. All right, so that's pretty clean. So now that we have that, basically at this point, all we need to do is add in a little bit of logic in our animation blueprint to basically connect this in. And when I connect this in, we are going to have to do a little bit of deleting what was there, or at least explaining what was there before. So let's go ahead and hop in and take a look at what that looks like as far as just basically putting a bow on this and getting it all taken care of. Here we go. Okay, before we hop in and start connecting in our animation blueprints, we do need a couple variables that we're going to be working with and add two small things to this blueprint. So first, let's create a B lookat enable. This is a Boolean variable, and we're going to use this to give ourselves the option to shut it off entirely or not. And then the other thing that we're going to create is we're going to create the lookat position world space. And this is going to be a vector. So when our lookat is enabled, we want to use this lookat position world space. So how do we connect this in? So compile and save. What I want to do is on our construction, I'm going to add in an if here. So let's get our Boolean enable and let's just go with an if. If I type if, now this is not a branch. This is specifically an if. And what it does is it lets us pick between two values if, depending on whether the variable is true or false. So we're starting off as false. So the false value that we want is we want what we're currently using, because our lookat is disabled by default. And then if it's true, we want to just use our lookat position world space. And then we're going to connect that into the translation value. When we compile this, let's just double check. Everything stays the same. That's great. So now we have the ability to disable the outside lookat if we want to. And we do need one more piece, and that is going to be down here off of this sequence. I left this pen blank purposely because I want one more. This time we are going to use a branch. And what we're going to check to see is if the lookat is enabled, we want to actually set the position of this in world space to whoever is setting it, wherever it should be, whether it be your animation blueprint that's setting it or your behavior tree, whatever it happens to be. And the reason we're doing that is because it'll control where this is kind of pointing. So let's connect this in. And if this is true, all we're going to do is we are going to set the transform of a control. The control in this case is going to be the lookat world space. Okay, let's compile that. It does not like that. The minute I connect that in, all of our controls disappear. There is something about this that it does not like. So let's do this. Let's set our initial value to a vector. Okay, and what we'll do is this is our lookat. Let's try that again. Compile. There we go. For some reason, not having that vector set caused control rig to stress out. So we've got that now. So all we need to do here is we need to get the lookat position world space that we're going to be setting. I want to take this because this is in world space. I'm going to go from world. What this is going to do is it's going to take it from the world position into global position, which is currently our rig space, and we'll connect that in. Let's just double check that everything is still intact and looks good. All right, now at this point, we're almost ready to connect into our blueprints. We do need to make sure that these are instance editable and exposed on spawn. Instance editable, exposed on spawn. Awesome. Let's compile and save this. And now let's go do a little bit of animation blueprint work. So here we are. Currently our enemy is set up to use a blueprint, the enemy lookat blueprint. If we go into here and we open the enemy lookat animation blueprint, you'll notice that we basically have an idle plugged into our control rig. Currently our control rig is set to use method old. So let's change this to the method B that we just created. When we do that, this is going to be invalid. So let's refresh our nodes. And if you're doing this from scratch, literally all you need to do is drag out here, type control rig. Let's just do it from scratch, actually. Let's just drag out here, go control rig. So we're going to be using our control rig. And the control rig that we're going to use, we would set to, in this case, this is our method B. And we would plug this in. Now, we do need our variables. So if we compile this, we've got our pins. I want B look at enable, and I want the look at position world space. I want both those pins. And we have two variables already defined in our animation blueprint. Now, we'll connect these in, and I'll explain where these came from in a second. So, but they should make sense. Is the look at enabled, and what is the look at position and world space? Okay, the minute we do that, nothing should change about our pose because of the way we've set up our graph. And let's take a look at our event graph and see where these variables are coming from. This is the exact same thing that we did with the first look at method. Basically, for the purposes of the demo, all we're doing when we initialize the animation is we're getting the player, we're getting the controlled pawn, which is basically the skeletal mesh stuff, the pawn that's moving around. We're setting that as our target actor. We're getting the location. We're setting the look at world space. That's the variable, the value, and we're enabling look at. This is just for testing. You would probably set this a little bit differently depending on whether your character's doing a spell or whatever. But anyways, then inside of our update, this is important. What we're doing is we're checking to see if our target actor is valid. If it's not valid, we do need to get that position. So what we're going to do is it means that it hasn't been set, usually because maybe your target actor wasn't created when the enemy was created. So this gives us a chance to come back through here, get the player controller again, set the target actor, and set the look at world space based on the target actor's location. All right, then once we've done that, once again, we're setting look at enable. So this is all about enabling the look at. Now, one thing that is worth pointing out, the look at location, I'd got the target actor. I'm adding 88 in Z, which is up in Unreal. The reason I'm adding 88 in Z, the look at for, if you get an actor's location, you're getting the center of the capsule. The center, and I happen to know for the enemy, if we look at it, if we take a look at our capsule, you'll notice that our capsule half height is 88. So what's going to happen is that is going to make it so that our character is looking at our character at the head. If we set this to 0, this is the default. When we play this now, when our enemies look at me, he's kind of looking right at the middle of my character. But if we add in that offset that is equal to the enemy half height or the character half height of 88, now when I play, my enemies, they're looking at my head. That's where we want them to be looking. Okay, so now let's take a look and see how we did. We have everything connected up. It seems like everybody's looking at me. It's kind of eerie. It's kind of cool. And the cool thing is, what I want to show you is the difference in proximity. The enemy up on this ledge that I'm closest to, they're leaning over a lot further than the enemy at the back of the ledge. And as I come up here, we come around, they even twist around. It's kind of wild. So obviously there's things that you'll want to do to limit that. Maybe your look at is not enabled when the target is behind you. There's all kinds of blending stuff and everything there. So overall, what we've done is we have set up a second look at method. And this time we did it without applying any kind of offsets to our joints. By initializing, and the trick was initializing those controls to bake in the delta, the difference between where they are initially and the initial look at position that we did in that construction script when we got that value and fed it back in. So that wraps up our control rig, and we did it. We did it without having any baked in offsets into our joints now, so that our pose is clean. And a huge part of that is just the way I was brought up in character setup and rigging and animation. I like the input pose to be just what it is. What I put in there is exactly what it is. And the other part of it is it also is just, it does help with troubleshooting. figuring out what is going on. Is it, where's the offset? Now we could just disconnect the control rig, for example, but in this case it helps with troubleshooting. And 3, I know I have better confidence that the pose that we're seeing is either coming from an animation or a blending or something else, as opposed to a baked in offset that's just weird as part of the control rig. So that's why. A couple other things to note. You can enable or disable this with the Boolean. Great uses of that would be, for example, if your character is casting a spell, character is talking to another character. Those are pretty easy. They're just going to enable or disable. You may want to add this to a blend. Depending on how you're set up, how you're controlling it, when a character starts talking, maybe you blend on the look at, so that they're going to naturally blend to start looking at the person they're talking to. And it's going to be driven, it could be driven by your inputs, it could be driven by your behavior trees. It's all just going to depend on your setup. But overall, the core is here. It's a really fun project to do with control rig that I wanted to share with you all as a step. My one last caveat is I've been using this, testing with it. It seems to be great, but it is entirely possible that there are weirdnesses with it. So obviously, if you find those, share with the class. Also, as always, if you have any thoughts or feedback or comments, throw those down in the comments down below. And if you have a different way of potentially setting up a look at, or you have ideas for additional features, share those either in the comments or hop in the Discord. Let us know what you're thinking. As always, thanks for checking out the video. Don't forget, a lot of our tutorials and topics are in the live section. My name's Kevin. Hope to see you in an upcoming live stream. Take it easy.